In these problems, we're trying to determine the domain and the range of various functions. And remember, the domain is everything x can be, and the range is everything y can be. And a lot of times that might be all real numbers. So if you took a regular linear function like y equals x, or f of x equals x, you could put anything in for x and you'll get anything out for f of x. So that domain would be all real numbers, the range would be all real numbers. But let's look at some other problems. We have some special cases here. In this first one, we have a rational expression here. So what we want to do is be aware of what x can't be. And x can't be anything that makes the denominator 0, because that would make this function undefined. So what are the values that would make the denominator 0 here? Well, we have an x multiplied by another quantity. So if that x was 0, that would be not okay. So x cannot equal 0. And then this one, x squared minus 25. Well, x couldn't be 5 or negative 5 because that would equate to 0 inside the parentheses. So x does not equal positive or negative 5. And that is a statement of the domain. There aren't any other values here that we can't put in for x, so all the other values are fine. So we can write the domain like this. All right, let's look at the next one. This says find the domain and range of the relation, and we have it here 4y is less than negative 4. So the first thing I want to do when I'm given an inequality like this is just solve it for the variable, in this case y. So I'm going to divide both sides by 4, and I get y is less than negative 1. Now, when I have a simple statement like this that has y over here, that's a statement of my range. Y is the range of this function. So that tells me my range. Y is going to be anything that's less than negative 1. But what's my domain? What's x? Well, in this case, x is not involved in this, so x could be anything, which means the domain is all real numbers. All right, let's look at another one. So we're going to find the range of this relation, and we have x squared plus y squared equals 25. Hopefully you know that this is the equation of a circle. And you might even know that it's got a radius of 5. So if you think about that, and the range are the y values, it goes from negative 5 up to 5, right? And nothing outside of that. So that would be your range. Y is greater than or equal to negative 5 and less than or equal to 5. Another way to think about this is just look at the equation. If this is going to be equal to 25, the most you could put in for y would be a 5 or a negative 5, and that is if x is 0. And otherwise, those numbers for y, if you put in something else for x, would have to get closer and closer to 0. So whichever way works for you. All right, and let's look at this last one. It says find the domain and range of y equals the square root of x plus 6 plus 9. Now, when you see a square root symbol, your alarm bells should go off, because what's underneath this can't be negative, because we're not dealing with imaginary numbers here. So what numbers could x be to keep this not negative, 0 or positive? Well, you could put a negative 6 in there, or you could put in anything bigger, a negative 5, a 12. So x is greater than or equal to negative 6. That's going to keep that from being negative. And that is a statement of our domain. Now the range, let's think about this. If x is negative 6, the smallest it can be, this part is 0. And if x is some other number, this part is actually going to be bigger than 0. So the smallest y could be is 0 plus 9. And it can be as much bigger than that as it wants to be. So our range is going to be y is greater than or equal to 9. So that's a little work with the domain and range of some functions and relations. My name is Larry. I'm a teacher at EdVision's off-campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethisSchool.org. Thanks.